Taking a look at number 38. Okay, 38 says, what real number is not in the domain of f, where f of x is equal to 1 over x squared? Okay, let's just take a minute and process what that question is asking. All right, what do I mean when I say what number is not in the domain? Okay, so what number is not allowed to be in the domain? What does it mean to be in the domain, Clarence?
Allowed to be a possible value for x in that equation.
I love the way you said that. A possible value for x. So what I'm really asking you is, what number is not a possible value for x? Okay? Curtis, what is it?
0.
0. Okay, why 0? What's the problem with 0, Clarence?
Because you can't have 0 under a fraction.
Okay.
Divided by 0 because it's in there.
It's undefined, right? It's not possible. So we can't have a 0 on the bottom of our fraction. And if we did 0 squared, that would give us 0. So what this question is asking is, what are you not allowed to put in for x? And the answer is 0. X cannot equal 0. Okay? What if that said something like 1 over x minus 5? What would x not be allowed to be? Drew? 5, because you couldn't let the bottom equal 0. So it's not always that you can't plug in 0. It's that you can't let the bottom equal 0. Okay, what else do you want to talk about? What other questions do you have? Alex?
Could you also go over 41?
41, sure. Okay, so 41 gives us y equals x to the 4th. And the first question is asking you for the domain. So A is asking for domain. Okay, so we just said domain means possible values for x. So what I want to know is, what numbers am I allowed to put in for x there? Drew?
Any real number?
Anything, right? Is there anything that I'm not allowed to raise to a power of 4? No. I can raise positives, I can raise negatives, I can do fractions, decimals, 0. All of those weird things are what I usually check. But there's no restrictions here, so your domain is all real numbers. Now, this next question, I think is trying to lead you to the next answer. It's trying to lead you to the answer for the range, because it says, are there any values of x for which x to the 4th is negative? So I want to know, is it possible to raise x to the power of 4 and get a negative something? No, why not?
Because when you multiply something like a negative sign, you will by another negative sign will be a positive.
Perfect. So I've got a power of 4, which means whatever I put in there, I'm multiplying 4 times. If I put a negative in there, what's going to happen if I multiply that negative 4 times? Become positive, right? So everything in here turns positive. Everything I put in turns positive. So no, there are no values of x that would let me get a negative answer. And that leads you directly to the next question, which is asking you about the range. Okay. What do I mean when I ask you for the range? The y, which is like the answer that you get, right? So I want to know, what possible answers can I get from this problem? Yeah, we just said that we can't get negative numbers, right? Now I want us to be a little bit careful. We can get positive numbers. What else can we get? 0. So we want 0 and all the positives, because remember, 0 doesn't count as a positive. So I would probably list it like this: all real numbers greater than or equal to 0. Do you see how that's really saying the positive numbers, but it also includes 0? Okay, so that would be your range for that one. Good? Does that make sense? Okay, what else do you want to talk about? 14. Okay, 14.
Like I don't understand like when it has like a addition or subtraction and then parentheses like that.
Oh, great question. Glad you asked that then. Because I'm sure you were not the only one confused by that. 6a minus 2 minus 2a. Okay, what that minus out there is really saying is everything in the parentheses needs to be subtracted, okay? Which is really the same thing as turning everything in the parentheses negative. So I'm going to have 4 equals 6a. This part stays exactly the same. And then this negative sign is going to make that 2 turn into a what? That's going to be a negative 2 or a minus 2. What happens if I minus a negative 2a?
Positive.
Yeah, I've got a minus and a minus, or a negative and a negative, so that becomes a plus 2a. Benny, did you follow that okay? Okay. Now over here on the right, I can just combine my like terms. So 4 equals 6a plus 2a is 8a minus 2. And then from here, I'm sure you guys are okay, but let's add 2, add 2. We get 6 equals 8a. Divide by 8, divide by 8. Kind of a weird answer. It's 3/4. 6/8 reduces to 3/4, or it's 0.75. Either one of those would be okay. Good? Okay, what else? Sarah? 15. Okay, so 15 is actually pretty similar to 14. I'm going to put it right next to it. So 15 says 3 minus m plus 2 equals 4m. Okay, so what is going to happen with this negative sign? It's going to distribute into the parentheses, not the 3, just the negative sign. So I'm going to have a minus m, and then this is going to become a minus 2. And usually with those problems, what happens is most people get the minus m, but a lot of people miss that that would also become a negative. Okay? Let's combine the 3 and the negative 2, so that becomes a 1. So now I just have 1 minus m equals 4m. What's your suggestion for what I do next? Yeah, let's add m. Let's add m. So that's going to give me 1 equals 5m. And then just be careful which way you divide here. I'm trying to get rid of the 5, so let's divide by it. And again, that's going to be either a fraction or a decimal. I don't care. It's 1/5, or that's the same as 0.2 would be your m value. Good on that one? What else do you want to see? Benny?
Like in 29, 30, what's the a and s?
Oh, great question. Okay, so let me push this in here. So this here, we didn't really talk about this, but this is a button on your calculator. Okay, this ANS. On the graphing calculators, I believe it's above the negative key or the decimal point maybe, and I can't remember. Oh, above the negative key. Okay, so what that means is, I'm probably using a dead calculator here. Yeah, it brings up your previous number. So my first term in this one, for example, would be 16. And then for my second term, I would do 16 minus 5 and get 11. Then you'll see that if I just hit minus 5, see how that ANS automatically pops up? Or if it didn't, for whatever reason, you could hit it. You could hit second and the negative sign and bring that up. But what that's really doing is saying to your calculator, use my last answer. So I'm going to do minus 5 and get 6 again. And then I can hit minus 5 and get 1. See how that's making my sequence for me? Okay, that just over and over again. And actually, once you have that ANS plus 5, you could, or sorry, minus 5, you could actually just keep hitting enter. And it would just keep subtracting 5 every time. Okay? So it's just your calculator's version of doing a recursive formula. So let's see, it wanted your first 5 terms. I think I had our first 5 terms. First term is given to you. So this is number 29. First term was 16. What would the next one be? 11, because it's minus 5 every time, right? So 11, and then 6, and then 1, and then negative 4. Okay? And you'll see they were up here higher, but I just kept going. Okay? So there's your sequence. And then it wants you to rewrite that same thing in recursive form. Okay? So recursive form, that first piece is okay, right? Saying T1 equals 16. And then for the second part, Tn, what would I replace that ANS with? Yeah, it's just using that notation. It's T sub n minus 1. That means the same thing, right? T sub n minus 1 minus 5. And then I suppose I should say for integers greater than or equal to 2. Do you remember, by the way, though, that this does not really mean a whole lot to us? I mean, it's important mathematically, but what is that really saying? What does n represent in these problems? The term number, right? So this is saying use this rule for terms 2 and above. Okay? So we have term 1, and then starting at term 2, you use this trick or this rule. Okay? And it has to be integers. That's just your way of saying you wouldn't want to do like term 1.5. That wouldn't really make sense. Okay? So really all you had to do for part B was rewrite exactly what was there, but instead of this ANS thing, put that T sub n minus 1. What else would you like to see? Happen. 43. Good, I'm glad you're jumping ahead a little bit. Okay, 43. The dimensions of a building are 100 times as large as the dimensions of the model. Okay? So if on the model the floor is X centimeters long, let me just write this down. So 43, if the model has a length of X centimeters, and I want the actual, what do I do to that X to show that it's 100 times larger?
Multiply by 100.
Yeah, super easy. This is way easier than it sounds like it is. This just wants you to do this. 100x centimeters. This is really your answer. Okay? You don't have to solve anything. You don't have to do any math. This is going way back to that very first lesson where we were just practicing, like, how do you turn this expression into, like, this word, this verbal expression into an algebraic expression. Okay? Just wanted to know, can you do 100 times larger? There you go. What else would you like to see? Allison?
48, please.
48. Oh, yes, 48. It's kind of a tricky one. So, Juana can mow the lawn around the family business in C hours on the mower. Okay? So, here's your C hours, let's say. And I want to break it up into 1 hour pieces. Okay? Because I want to know how much can she mow in 1 hour. How much would each one of these pieces be? If the whole thing is C, and I split it up equally.
100% divided by C.
Okay, so 100, and then, I like the way you said that. I'm going to write that down. 100% divided by C, because I took that 100% and divided it up among the C hours. Numerically, what is 100%? 1. So each one of these pieces is 1 over C. Does that make sense? That if I added up a bunch of 1 over C's, it would just equal C at the end? Right? That 1 over C plus 1 over C plus 1 over C, if you added that up C times, you would have C over C, which equals 1. Okay? So for Juana, in 1 hour, she can mow 1 over C of the lawn. Okay? This is how much work she can get done in 1 hour. And I think that's what question A asked. In 1 hour. Okay? That's part A. So then thinking about that same thing, Rosa can mow the lawn in D hours. So what would I say for her for 1 hour? 1 over D. Yep. So she can mow 1 over D. If they're working together, what can they mow? Careful, because they're not common denominators. Okay, what?
1C plus 1D.
There you go. That's what I was looking for. I would add them together, right? I was just going to come up with a numerical example for that, but let's say, oh, I don't know. Who's going to be my guinea pig? Benny, since he got the right answer. All right, Benny and Ryan are mowing the grass together, okay? Benny can mow 10 square feet and Ryan can mow 5 square feet. And I want to know how much can they mow all together? What would you do? You'd add it, right? Really easy question with numbers. Always sounds harder when you're working with these crazy things, but just focus on like what is that really asking? I'm adding together how much she can do with how much she can do. Okay? So this would be your answer for part C. It's kind of a tricky one, but that's how you would handle that one. How are we doing on time? We're okay. Anything else? Gloria.
Number
57? 57? Okay. 57. Okay. Oh, that was nice that they gave you the equation already. I was going to make you write the equation. All right. So, baby blue whale weighs 4,000 pounds at birth. Does that terrify anybody? Like 4,000 pounds the day they are born. Okay? And then they gain 200 pounds a day. That's like a human adult male per day. A big human adult male per day. Okay? So a formula that gives its weight after D days of nursing is given to you there. So like I said, they were really nice to give you this formula. Their weight is equal to 4,000 because that's how much they're starting at. And then they're adding 200 per day. So does the setup of that equation make sense to you? Starting at 4,000, adding 200 per day. So part A wants you to rewrite the equation that would let you find out how long it would take them to reach 14,000 pounds. Where am I going to put 14,000? The weight, right? I want them to weigh 14,000. So 14,000 equals 4,000 plus 200D. And then I don't know why they have this as a separate part, but part B is where it wants you to actually solve that. Do you feel like you can handle solving it? I bet you can. Subtract the 4,000. Subtract the 4,000. So I get 10,000 equals 200D. And then divide by the 200. And I believe I get, let's see, 50. So 50 days equals D. So a little less than 2 months. And that whale is 14,000 pounds. And then notice what it says. Baby whales nurse for 5 to 7 months. Oh my word. This is less than 2 months and they're at 14,000 pounds. So that's a terrifying idea to me. Okay, probably time for one more, if we need one more.
Can you do the salary?
49? Sure. Okay. So this is really an explicit formula in disguise here. And again, they wrote the formula for you, so that's kind of nice. Thank you, math gods. For 49, they tell you that the sentence A sub n equals 26,000 times 1.06 to the power of n minus 1. That's going to give you how much your salary increases each year. And then it says, write Sandra's salary for the first 5 years. Are we super close on time?
No.
I feel like you guys are rustling papers a lot. Let's get through this one before we pack up, okay? So part A wants her salary for the first 5 years. So if I want the first year, what am I going to plug in? 1. Yeah. So I'm going to go 26,000 times 1.06, and I'll write out the first one, but I don't know if I'll write out every one. 26,000 times 1.06 to the power of 1 minus 1, which is really 0, okay? Which means that your first year, your salary is just 26,000. From here, you guys, okay if I just plug this straight in the calculator? Probably, right? So for my next year, I would do 26,000 times 1.06 to the power of, and if you're putting more than one thing in the parenthesis, you should put it in parentheses. No, I'm sorry. If you're putting more than one thing in the exponent, you should put it in parentheses. So if I want the second year, I'm going to plug in a 2. So I'm going to do 2 minus 1. There's her salary for the second year, $27,560. For the third year, I'm just going to make that a 3. And I get $29,213, and don't forget about those 60 cents. For the fourth year, make that a 4. By the way, do you know how I'm doing that on my calculator?
No.
Oh, you need to know that, because look at how easy that is. If you hit second and enter, it brings up exactly what you typed in before, but it lets you edit it. So I can hit second and enter, and now I can just go back to that 4 and say, okay, now I want that 4 to be a 5. Oh, you can't see. I'm sorry. All right, let me try that again. So if I hit second and enter, I want that 3 now to be a 4. Or was it? Actually, I'm on 5, aren't I? It's because I redid it. So I want that to be a 5, so I'm going to type in a 5 and then hit enter, and it gives me the answer, instead of retyping it every time.
That's nice.
Okay, isn't that nice? Now, so that right there, and again, you can do that on your own calculator to get those 5 answers. The second part says, what would her salary be after 20 years? Do you have to keep going all the way to 20? No, we can just plug in 20. So I'm going to hit second enter, go back to the 5. Now this one, you may have to retype here a little bit because it's going to kind of type over what you already had there. So 20 minus 1, and there's your answer for part B. $78,665. That's money, so I would round to 59 cents. And really, salaries usually don't involve cents, so you could even just round to the nearest whole dollar. Okay, so I should let you know